Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant Puzzle. This one is called You Have a Train to Catch. It's an easy problem of probability kind. So just to explain the problem real quick for you guys. So we're Spider-Man and we've got two close friends, Mary Jane and Gwen Stacy. Come back to the central subway. We either meet up with Mary or with Stacy. Now, what happens is there are two trains. One goes towards Mary's station and the other goes towards Stacy's station. Each leaves every 10 minutes. So let's say T1 leaves for M. I'll just call M and S from now on. So let's say T1 leaves for M at 5 o'clock, right? So at 5:10, again, T1 is going to leave for M. At 5:20, again, 5:30, 5:40, and so on. And for example, let's say that T2, which is the train that goes from the central subway to Stacy's place, or S, leaves at 5:04 p.m. Then that means that at 5:14 p.m., it's going to leave again. And then at 5:24 p.m., and 5:34 p.m., 5:44 p.m., and so on. So now what we've been given is that we as Spider-Man come at any random time of the day, right? And we always board the train that which departs first from our station. And what we've been observing is that we end up visiting M 9 times more often than S. And we have to decipher why. So the solution lies in the time gap between T1 and T2. So let's say T1 leaves at 5 p.m., as we just mentioned, right? And then at 5:10 and 5:20 and so on. And T2, since that is random, could be departing. And I'm talking about the time gap between 5 o'clock to 5:10 p.m., since each train has to be leaving at a particular time between those two, since each train has a frequency of 10 minutes. So that means that it is guaranteed to depart at least exactly once between every 10 minutes. So let's say this is 5:06 x p.m., right? So there's an x minutes gap between T1 and T2. So T1 comes, and then after x minutes, where x is going to be between 0 and 10. So after x minutes, T2 comes along. And then after 10 minus x minutes, we get T1 again. And then after x minutes, we get T2 again. And keeps on continuing this way, right? So what ends up happening is that we as Spider-Man would be coming from any random time between 5 o'clock to 5:10. Again, this could actually be some completely other time. It could have been 6:54 p.m. or something, but every 10 minutes is the exact same scenario. So I'm trying to like generalize it over here. So let's say we just happen to come at 5:00 p.m., right? Where t is again somewhere between 0 and 10, right? So what is the probability that we are going to take up train 1? And what is the probability that we are going to board train 2? So since for the first x minutes, that would mean that we would take up train 2. And for the next 10 minus x minutes, that would mean we would have to take up train number 1, since those are the trains that would come first in each scenario. So the probability to take up train 1 becomes 10 minus x upon 10, because we could be uniformly, so the value of t could be uniformly distributed among this time frame, since it's completely random. And the probability to take up train 2 is the probability that t comes within this range over here. This becomes x over 10. So since it's given to us in the problem over here that we observe that we end up visiting Mary 9 times more often than Stacy, which means, so this is 9 times more than this, which means we aboard this train 9 times more times than this train. So this is what the question is saying, right? Probability of getting on train 1 is 9 times more than the probability of getting on train 2. And we also know that these two have to be equal to, or their sum has to be equal to 1, since these are the only two cases. By these 2 points, this point and this point, we get that the probability to take up train 1 is 0.9 and the probability to take up train 2 is 0.1. So since probability of train 2 is x by 10, bring that over here, x over 10 is equal to 1 over 10. That means x is equal to 1. That means that there's a 1 minute gap between the trains. And it's also important to know which train comes after which for that minute gap. So over here, we said that T2 is going to come 1 minute after T1. So the train for Mary's Place comes, let's say, at 5 o'clock. Then the train for Stacy's Place comes at 5:01. And then for the next 9 minutes, we end up waiting for T1 again, which is the train that goes to Mary's Place at 5:10 p.m. So this is the solution. The solution is that the train that goes to Stacy's Place comes 1 minute after the train that goes to Mary's Place. And then the next train that comes from Mary's Place comes 9 minutes later. So since there's a 1 minute gap over here and there's a 9 minute gap over here, and we have an equal probability to come at any of the 10-minute time frame, so it's 9 times more probable to come in this time frame, which is 9 minutes long, compared to this time frame, which is just a minute long. And it's also important to remember that the train that goes to Stacy's Place is the one that comes 1 minute after. I hope you guys understood this solution, and thanks for watching.